Hi, my name is Connor and this is my bucket sorting algorithm video for the data structures at University of Delaware. So what is the bucket sorting algorithm? The bucket sorting algorithm is a linear sorting algorithm. It follows a divide and conquer principle. The divide and conquer principle states that sorting smaller chunks of data in multiple groups is easier than sorting a large set of data in one big group. So let's picture a scenario. Say you're living in a zombie apocalypse and come across 100 zombies blocking entry to your home. Wouldn't it be easier to divide 100 zombies into groups of 10 before attacking them? Your chance of being bit is much smaller while facing 10 zombies at a time rather than 100 zombies at a time. The bucket sorting algorithm works on this principle. So, what does the time complexity for the bucket sorting algorithm look like? O of n is the name of the game for the bucket sorting algorithm. O of n is its average runtime as long as its best runtime. However, its worst case runtime is O of n squared. Now, this is a very rare case where all the data falls under one bucket, so it's almost as if no buckets were even made to begin with. And as you can see on the graph on the right, O of n is about the third best time complexity, while O of n squared is the third worst. So O of n is one of the better time complexities for an algorithm to fall under, while O of n squared is not so much. Is the bucket sorting algorithm stable? Yes. However, the bucket sort only divides the data into buckets. It technically doesn't sort the data once it's in these buckets. So the bucket sorting algorithm must rely on another sorting algorithm to sort the data once inside the buckets. In order for the bucket sorting algorithm to be completely stable, its sorting algorithm it relies on must also be stable. But in it by itself, the bucket sorting algorithm is stable. Now, what sort of data type works best for bucket sort? Uniformly distributed floating point numbers ranging from 0 to 1, including 0, but excluding 1 works best. So in the example data provided below, we have 0.92, 0.81, 0.77, 0.43, and so on. This would be, a random example of what you could use for the bucket sort. So how does the bucket sort actually work? Here are the steps. Step 1, create 10 buckets, which are really just 10 linked lists. And since we've allocated more memory for new data, this algorithm is not in place. So you can see by the 10 buckets below, as you can see, there are 10 buckets below, and each bucket is categorized as holding a numerical range of data that it holds. The first bucket, 0.00, holds all data with a tenths value of 0. The second bucket, 0.10, holds all data with a tenths value of 1. The third bucket, 0.20, holds all data with a tenths value of 2, and so on. Now, it's worth noting that the buckets itself aren't assigned decimal values. Those are just labels so you know where to place the data. Now on to step 2. Here we have the example data in an array. It holds 0.59, 0.81, 0.77, 0.43, and so on. Now you want to loop through the data and place them in the correct buckets. So as you can see in the visual on the right, this is what the new data should look like after the data has been assigned a bucket. The data is nicely distributed, and there isn't one bucket holding all the values, as that would be the worst case runtime, O of n squared. Step 2.5. Notice how the data is already sorted inside the buckets. As stated previously, the bucket sorting algorithm doesn't actually sort the numbers once inside the bucket. This is where insertion sort comes in for our example. The insertion sort algorithm works best with small linked lists, which is exactly what we have. The algorithm places data in linked lists and automatically sorts it for us. In this example, the algorithm the bucket sort relies on is the insertion sort algorithm. Now, it's important to note that bucket sort can use many other sorting algorithms and it does not have to be the insertion sort. Now on to step 3. Create a new array that is the same size as the initial unsorted array. So there's just a snippet of code on what that would look like. Now this new array will be used to store the new sorted data inside the buckets. Step 4, the final step, only 4 steps. Now in order, distribute the data from the buckets into the new array. So you go from bucket 1, traverse through all the nodes, Then you go to bucket 2, traverse through all the nodes, bucket 3, traverse through all the nodes, etc., and so on. Now, this only will work if the data inside the buckets are sorted. If they're not sorted, you have to sort them individually, and then you can distribute. But in our example, it worked because of insertion sort. So once distributing the data from the buckets, sorted mat in our example should hold 0.01, 0.09, and so on. So as a final review, the bucket sort algorithm is a linear sorting algorithm that works on the divide and conquer principle. The algorithm is stable, but not in place, as you have to create an array and 10 linked lists, and its average runtime is O of n with the rare risk case of O of n squared. Thank you.